Hello and welcome to this new tutorial. In this tutorial, we are going to do visually the pregnancy detection from pregnancy strips. So what we want to learn in this tutorial is, let us open an image consisting of this pregnancy strips. And then when we click on this and we get this result. So this is an invalid result. This is also invalid. This is not pregnant. And these two are the pregnant results. So this is what we are going to learn in this lesson. So let's implement this. From my previous videos, I am following this project. So I already created this project which uses Emgu CV 4.5.1. You can check one of my previous videos how I configured it. So what I will do is in this menu strip item, I'm going to add a new submenu item. So click on this menu item and into the collections and inside this tool strip item 2, which we can give a name. I should give it a name like process. So in this process, I'm just going to add another item inside it, and I'm going to add a new menu strip item, and we can call it pregnancy test, and we can give this item is pregnancy test and click OK. And from this menu strip item we can select the pregnancy test, and I'm just going to select the events and double click on this click event. So when we click on it, we will go into this event, and here I'm going to write a try catch block first so that we can handle an exception if we have. So we have already write a method to open an image, and as I have shown previously that once we open an image we write it into a dictionary. So this is the BGR dictionary. We give a string and then an input. So whenever we read an image it comes into the input. So we can first check that we have at least an image in the dictionary. So the first thing that I want to make sure that I have at least an image to process. If not, imgdict dot contains key, and this one should return true. Otherwise, if it is false, then we can throw an exception. Throw new exception, and we can say read any. Okay. Otherwise, we can process it and we can read it from the dictionary. So I can create a local variable inside this event. So we call it img is equal to imgdict, and I can use its key to read that input. So let me clone it so that I will make an exact copy of that. And we can also do one thing here. After cloning, I can smooth it so that we shouldn't have any problem. If there is a local noise, we can suppress that noise, and I'm using a kernel size of 3, which means that only neighbors 3 by 3 neighborhood, so 1 pixel around the center one will be used to smooth it using the Gaussian. And this is the image, and as you can see the background is white, and I'm not interested in the background. I'm interested in these items. So I can threshold it, first convert it into gray and then threshold it, and I'm not interested in the color. Actually, I will not use the colored. So what I'm going to do, I call it binary image first, img.convert into gray, and this is the bytes or the depth will remain the same. The next thing that I want to do is to threshold it, and we can use the threshold binary inverse, in which because we have the background is white, so to make it black, what I need to do, new gray, the minimum value that I want to use is 240, and I want to set every pixel that is less than greater than this one to less than this one, because I'm doing the inverse to this white one. Okay, so this one will binarize my image, and then we are interested in finding the contours, so that once I find the contours I will be able to get these strips. I hope that I'm getting those big strips. So what we will do is we will apply this function find contours, but to find that we need to have store those contours in vector of vectors, so vector of points. So we can call them contours is equal to new vector of contours. Okay, so I just created this vector of contours to store the contours, and also we need the hierarchy. So mate, we call it hierarchy, and I just want to create a mate object. Okay, so we can now apply the find contour function, cv invoke dot find contours, and this one is expecting an input image. So we have this binary image. We will provide this binary image, and we will store the contours in this contours object. The hierarchy information will be in this hierarchy mate file, and then we want to do is retrieval type dot external. I am interested in the external contours only, and let's use this chain approximation to be the simple one so that we will store only the required points, not all of them. So what I want to do now is, if we have some extra contours, maybe in the image we don't see them, I can apply basically some area threshold and remove those areas which we are not interested in. So we will select those contours only. So I need to loop through these contours. So for what we can do, integer I is equal to this, and the contours dot size. So I'm looping through all the contours, and I'm going to apply a threshold on the area, for example. So we need to first calculate the area for each contour. So we can calculate the area for each contour by using the cv invoke dot contour area function, and this one is expecting us a contour. So we can pass in our contours one by one using this index I. So this one will give us the area of the contour, and I want to apply, for example, we can declare here, initialize it, for example, integer threshold or double threshold is equal to, let's say we want to remove the contours which are less than this area. And what we can do, if the area of the contour is greater than our threshold, then actually we can create another contour here, a vector of points. So I call it vector of points, and we call it the filtered contours. Contours is equal to new contours. So if our contour has area greater than this one, then what I will do, filtered contours dot push. I want to add it into my new contour. So this contour, I'm going to push it since its area is greater than my minimum threshold. Okay, so once we have these contours, filtered contours, we can, by the way, draw these contours if if you want. Also, if you want to visualize them, also we can draw them. Maybe we can run a loop, or maybe what I will do here is just for seeing what actually we are getting, because we need to look at the output, then accordingly we need to adjust our requirements. So I can create a new binary image, copy blank. So this one will generate a same image as the size of this output, where all the pixels will be set to 0. So I want to draw those contours. Output dot draw. In fact, I can use that cv invoke dot draw contours. And here I'm going to draw on the output image, and the contours that I want to draw is all the contours, give all the contours, And then this one is asking for the ID, and we know the ID is I. And we can give a color. So since it is a grayscale, so 255, that will be the contour. And if you want, you can fill it also. Just I want to keep the thickness to be 2. Let's see if we have done filtered them out or not. So once we have that picture box dot image, we can draw that image output dot to bitmap. Remember that if you want to use this to bitmap, you need to add this package cv.binary. This is separately added into when you are installing it. So let us run it and see what we have received so far. So this is the input image, and I just want to test it. What is it? So exactly this is what I wanted. I needed these contours of the pregnancy. Now once I have these bounding areas, I want to process them one by one. Using these bounding boxes, I will crop this original image. And what I want to do is, once I crop this image, then I will again find the contours. So when I find the contours, at least I will have these many contours inside it, and I will apply another threshold so that I will have these big contours, at least this white area, this one, and this region can be different contour objects for me. And then I will sort them out using the x-axis, and then I want to just remove the left ones, and only these contours I just want to select. So now I can process it. So instead of drawing, I just need to check it. So I'm going to comment this. And then now I'm going to loop through all the filtered contours for integer I is equal to filtered contours dot size. And here, what I will do again, I will apply some threshold conditions and all those things. So variable bounding box, I just want to get the bounding box. And using this bounding box, I will be able to crop the original image. So we will have this area only. Now I am going to process only this area, not all of this area. So bounding box is equal to cv invoke dot bounding rectangle, and over here we pass the contours. Every contour this I'm going to pass one by one. And once we have the bounding contours, and now to crop only that area, what I will do, I will use this ROI. So ROI is equal to bounding box. So only that area will be processed. And similarly for the output image that I have just created, for that one also ROI will be bounding box. Now I have this binary part. I want to process that binary part. Maybe I should create a different function here. So I'm going to call this function is private, and this one will return me the list of rectangles, which will be the bounding boxes for this area only. I mean, I just want to extract this part. So the left two parts I want to leave. This will not be detected. Only this part just I want to select. This, as you can see in all these strips, we have these two contours which I will remove them. Only this area I want to read. So how I will do that? So this is one will give me the rectangles for this region, because this region might have one rectangle only, or maybe two rectangles, or maybe three rectangles, and based on that we will decide. So I'm saying this name to be process parts, and inside it we are going to pass an image, and this one will be a gray image, gray, and depth will be the byte, and we can name it like img. Okay, so we can again use a try catch, and if we have any exception we can throw a new exception, and whatever written in the message we can throw it. and this one will be actually catch over here. So inside it, we need to create some rectangles. I need to declare some variables. So rectangle is equal to rectangle dot empty. Okay, and I just need to do here this image. As you can see, this will be this part. I'm interested in processing this border region, not this lake region. I'm interested in this white region. So what I will do is img dot not, but this one should be an in place or in memory not. So when we have this underscore, it means that it is directly changing this img value. Because as you know, I am working with this binary image, and I will be working with this binary image in which the background is black and the others are white. So I want to make this region to be white again. So that's why I need to apply this not. And once I apply this not, again, I'm going to find the contours. I call them contours the same way we did it. So new vector of point, we can, and also for the hierarchy, I call it h is equal to new mate object. Okay, and now we can again find the contour for the specific region or each strip. So find contours, and here the image will be img, and we want to store the contours and contours, and hierarchy, which we don't need now. Retrieval dot, we need only the external contours, and the chain approximation dot simple one. That's it. And now once we have those, the interesting thing is to filter those contours, and we need to return this list of rectangles. So I'm just going to create a list of rectangles, or which we call them the bounding boxes, is equal to new list of rectangles. Okay, we will return them. And now I need to loop through all the contours so that I will filter them out. So for I is equal to 1, and the contours dot size, and here I need two things, the area and the bounding box as well, because I need the bounding box to be returned. And let's say we want to find out the area is equal to, what we can do is cv invoke dot contour area, and here we can pass the contours, and we just pass an I. So once we have the contour area, just same as before we did, we can apply a threshold, double area threshold is equal to, we can, it will be specific to the task. So for here, I hope that it will work okay for 200. So here we apply this condition if the area is greater than our area threshold. Area threshold, the spelling can be corrected, and then we can filter that out and add into bboxes dot add, and we can just do what, this contours or this bounding box. In fact, we also need to find the cv invoke dot bounding rectangle. I need this bounding rectangle, so I just need to pass this contours of I. Okay, so this bounding rectangle will return the bounding box, and we add it into this bounding boxes, and for each region, for each contour within this region or within each strip, we calculated them and return them. Now of course it will, because I did the thresholding, so this area will not be returned, and I hope that only this white region will be returned, which means that we will have 1, 2, 3, 4 controls. I applied this threshold area, and now the right side ones I want to drop these two. Of course, this one and this one, these two are always here, and I need to just drop them. So only this area will be returned in the bounding box. So what I will do in the list box or the bounding boxes list of rectangles, all these are present here. So if I sort them out using their x-axis, so this one will be the first, this one second, third, fourth, and so on and so forth. So I just want to remove the last two ones. So I just will do one more thing here. Variable sorted bounding boxes, we can write something like this. Now to sort the bounding boxes present in B box, we can use order by, and here I am going to use a lambda expression, let's say B, and B dot according to its x-axis. I just want to sort them by x-axis, okay, and a dot to list. Okay, so this one will order our bounding boxes according to their x-axis. So we will have the first contour in the first place, the second one in second, so on and so forth. Now I want to drop these last two. So, but to make sure that if its length is greater than is 2, it should be greater than 2 box dot. We can do count is if it is greater than 2, then I would like to remove those two. Dot remove range. I just want to remove, and to remove them, what I will do, sorted boxes dot count how many, -2, and just I want to remove 2 out of that. So this one, what it will do, it will remove last two contours, which I hope that we will have 4 and the last two ones, whatever I just removed. Else, it should, if it is less than 2, then it is not a good thing for us. I just want to sort it dot clear. We don't have anything. We are not interested in that, because as we can see in the strip, we have more than one in each strip. And then we can return this rectangle, return the sorted boxes. So this method is actually processing each of these regions, and return us, hopefully by removing them, it will return all the bounding boxes in this region. So if this, in this case, it will return 2, in this case 1, in this case 2, in this case 3, and 3. And you can see that in case of a positive, then we will see that there should be 3. In case of negative, we will have 2. But in case of invalid, no, only 1. In case of this invalid, there is also a problem, because you can see this negative and this one are almost same. So what we will do is we will also see the area on the left one and the area on the right one. So we need to put some conditions here. So here, what I will do is, once we have the contours and we can process each of these regions, I can write it variable rect. We will receive the rect using this process parts, and in this process parts, I will send this binary image. And remember, once we process it, we need to reset this ROI back to the empty. Remember this one, don't forget, rectangle.empty. Okay, so we can get the number of contours that we have. So integer count is equal to rect, depending on the number of rectangles that we have received, or the bounding boxes. Now I want to switch and directly apply some conditions here for the valid, invalid. So if there are 3, it means that this is the case of pregnancy. In case of 1, then it is invalid. But in case of 2, we have to make a decision, further condition, and then see if it is true or if it is invalid, or if it is what we call it negative. Okay, so I'm going to apply a switch statement here, and I'm going to apply a switch on this count case. If this one is equal to 1, this means that we can actually display a message also. So what I will do, I need to create a string outside, so we can display a string, and we don't have anything in the beginning. And to display the string above or below somewhere, I define a margin also. So I just write these two things I will use to display a message down there. So if we have only one contour, then the message rectangle, then the message is clear, it is invalid. We want to show that in front of this one, I want to show it is invalid because there is only one contour in this region. And we can set a, also I forgot, maybe we can also display in a different colors if we want. So MCV color scalar, we can call it color is equal to new MCV scalar, and by default we can give 0, 255, 2 or 0. That's a green color. And if that is the case, the color can be color is equal to new, and for invalid, B will be 0, G will be 0, and it will be in red color, R. And we can put a break. Okay. In case if there are, let's say, 2, then this is the complicated situation, because this is also contains 2 bounding boxes. This will also contain 2 bounding boxes. So I can put a condition, but you can see for the not pregnant case, this area is less than this area. Or if we find the area of this contour, width multiplied by height, it should be less than width multiplied by height by this one. So that will help me to decide. So what I will do in case of 2, if this rechts of 0 multiplied by rechts of, this is the width, rechts of 0 dot width multiplied by the 0 dot height. For the first contour should be, if it is less than rechts of 1 dot width multiplied by rechts of second multiplied dot height. If it is less, then it is clearly indicates that it should be basically not pregnant case. So we can write the same thing. I'm just going to copy that. In fact, I should do something. We can copy that, paste it here, and the message will be not pregnant. And this break should be outside. In fact, the color should also be somewhere here. Color should also be here. Okay. And if that is not the case, the only message we are going to change. If that is not the case, the message will be basically the invalid. If this area is not less than this one, then it is invalid. Test is not valid. So this will be the case number 2. And the third case in which we have is this one. Both are pregnant. So we have 3 bounding boxes. So we can write case 3. And in this case, we can say message is equal to pregnant. And we can set this one also. I'm just going to copy both of them, paste them here, and then we can show a green color actually, BGR. And to make sure that there is no any problem, none of above is selected, then we can also show a message. it can be either invalid or this is not pregnant, or we can say just it is invalid. But to make sure we have a different message, so I call it pregnant. Okay, and the color will be the same as we do, like the above one, and here we can put a break. Okay, so this switch statement will make a decision, and just after the switch, what I would like to do is to display the answer for it. This is the for loop, and just before the for loop, I just want to put a text message CV invoke dot put text on this image, on the original image. So we can give this message, show us the message, and where we want to put this message, we need to give a point. So we have the bounding box already for this region, as we have the bounding box dot the x-axis plus bounding box dot width, whatever the width outside. I just want to put it bounding box plus its width. So somewhere here I want to write. We can add some more margin here, so it should be outside margin. I have written margin. It's okay. I'm just going to write it margin. Margin here will be x-axis and the y-axis will be bbox.y plus margin. Okay, we put a margin over there, and if we want, we need to give a font face. Font face dot whichever you want to select. I'm just going to select the plain one, and we can select a scaling of 1.5, and we can give the color that we have selected, and its margin or its font thickness, I just put it as 2. Now once we have this message, and we can display it as in our picture box. So let us see if it works or not. Let me open a file, and when I click on this pregnancy test, so here is what the exact result we have. So this is the invalid case, this is also invalid, this is not pregnant, and this shows this is the pregnant. So that's it for today's tutorial, and hope to see you in next tutorial.